Okay, so we're able to start now. And what we're looking at here, homework set number 15 is what's due for today. As you might have noticed, hopefully, homework set number 15 is not on the online set. It's a separate sheet of paper, actually 2 sheets. And after having worked on that for a while, maybe you got that figured. Homework set number 16 is online, the regular place. Okay, so homework set number 16, you go back in the way you've done it before, work through the thing, input, all that jazz. Homework set number 17 is not out there. Okay, homework set number 17 is the same as homework 15. Okay, so you'll click on that, you'll see a thing, you'll do a thing, right? So 16, which is due next time, is online. 17, time after that, is not. It's on here. Okay, PDF, whatever. All right, and then we're done with assignments at that point. And we get ready for exam number 4. As it turns out, exam number 4 is not a comprehensive final exam. It only covers the material on Unit 4. I'll be prepared to answer that question about another half a dozen times. But for right now, I just want you to know, exam number 4 is not a comprehensive final. It's just going to cover the material from Unit 4. All right. So what we're going to do right now is we're going to kind of go back a little bit. We're going to make sure that you're confident. Well, let's just say you're getting there. Your understanding on correlation and regression will probably need a little bit of a boost here. And then we'll talk about homework set number 15. We'll go over it. And how this works is that if you have something wrong on homework set number 15, you can correct it. And if you then turn it in, that'll be just fine. Okay, my goal is that everybody gets everything right on homework set number 15. Okay, so yeah, I think I'll try something that I haven't done previously, just to make things interesting. So what we're going to look at right now is the relationship between the poverty rate and the violent crimes in the state of Wisconsin. Okay, so what I'm going to have is I'm going to have the x-coordinate be the rate of poverty, and the y-coordinate is going to be the violent crime rate. Okay, so for each of these different counties, I'm looking at 2 different numbers. Poverty, crime. Would it seem to be logical to consider these numbers? Would you think that poverty is related to crime? I would think maybe so. I'm not a social scientist, but I think it might be. So we're going to find out if it is. Okay, so we're going to make this happen. And we're going to do regression, linear, poverty, violent crime rate. And we're going to compute that. Okay, so what we're going to talk about first is, pardon me, correlation. What question is going to be answered by correlation? Can somebody tell me what question that answers? Is there a linear relationship? Okay. And in order for that to be figured out, what are we going to do? How are we going to answer that question? We're going to do a hypothesis test. Yes, we are. All right. Danielle Cope, what's the first thing we do when we do a hypothesis test? We're going to determine null and alternative hypotheses. Danielle, can you tell me what they are in this situation? Okay. Casey, can you tell me what the null and alternative hypotheses are here? No. In general, when we're doing
H0 with the P, right?
No. Row, yes.
Like the P.
It looks like a P, but it's not. It's a row, yes.
Equals 0.
Equals 0, that's right. And the alternative?
H1 row equals no.
Does not equal 0. Okay, now I want to know the meaning of those things. Casey, can you tell me what they mean?
The first one, no linear relationship.
Right.
I thought there is a linear relationship.
That's right. Okay, there we go. Yay. Look at that. Okay. Evie, what's next? We do. We need to find critical values. Can somebody tell me where critical values are? Table I. Somebody tell me where I find table I. Page 658 in the textbook. As they say these days, boom. All right, so here we are. We have how many data values? We have 13. Each county is a data value, okay? There are 13. So how many degrees of freedom do we have? 11. So if I look at degrees of freedom 11, and I'm going with an alpha of 0.05, I have 0.553. Degrees of freedom is equal to 11, alpha 0.05, critical value 0.553.
Is it the same for correlation that if alpha isn't given, it's 0.05?
Yes. All right, Haley, can you tell me what I'm supposed to do with that number?
If you draw out
Okay, what does my graph look like?
you have 0 in the middle, and then you have -1, positive 1 on each side.
I do. Where do I put my 0.553?
Probably like the middle of both sides.
Okay, I put it on both sides. It's a two-tailed test. Emily Yang, can you tell me what I do next? Okay, I need a test value. But there's one thing I also need in here. Eric, can you tell me what I need on my graph? No. Okay. Anybody tell me what I need to do on my graph yet? Taylor. Okay, which would be where?
To the left of -0.553.
Okay, so I'm going to shade in over here and over there. Okay. Now, what's my test value? Don't know if you can see it on the screen there. Eric, you're in the front row, so maybe you can read that from where you are.
Are we looking for the test value?
I'm looking for my test value. Yes, I am.
Which one do you want?
The correct one. I want you to look at these numbers and tell me which number is the test value.
0.804.
0.814. Might be hard to read, but 0.81. Okay. Kelly, what happens next?
You put
at, after the 0.553, draw a line.
Okay. So what does that tell me?
That you reject the null hypothesis.
I reject the null hypothesis. Okay. Amanda, can you tell me what happens when I reject the null hypothesis? We prove the alternative. And specifically, I say there is evidence to prove the alternative. So, Amber, what do I say? Okay, there is evidence to prove the alternative. Amanda, can you tell me what I say?
Let's start it. Let's stop it.
Okay, all I want is just a simple thing. If I say there is evidence to prove the alternative, what does that actually mean for this problem? Amanda, can you tell me what that means for this problem? Kelly, can you tell me? There is a linear relationship. That's the alternative. The alternative is there is a linear relationship. So that's what I say. There is a linear relationship. So right now, according to this, according to my numbers, there is a linear relationship between poverty and crime rate. Okay? That's correlation. Right? Now, I also want them to do regression. Allie, can you tell me what regression, what that question is asking?
What is the formula for the relationship?
What is the formula? Okay. So I have proven that this is strong enough to count for this. And now I'm going to say, what's the formula for that? Okay. So here's the formula. Violent crime rate equals -308 plus 43.8 poverty. What that means is 43.8 multiplied by a poverty number, and then plus this negative number would give us violent crime rate. So I'm going to write this as y equals, or y prime, I should say. Y prime is equal to -308 plus 43.84x. Allie, can you tell me which is the slope? Which of these numbers is the slope? 43.84, that's the slope. It's the number that is in front of the x, it's the number that's being multiplied. And then the -308 would be the intercept. Okay, so this here is our formula. Emily Grenier, can you tell me, should I trust this formula? No, can you tell me why I should not?
Because the numbers can change.
The numbers are going to change. This is just a sample thing. So if I do another one of these, it's going to change. So I should not believe it because of that. Why else should I not believe this?
The relationship doesn't mean we know.
That's also true. Even though we have a relationship, that doesn't tell us that poverty is causing crime or crime is causing poverty. We don't know those things. So we shouldn't assume that this is telling us something. Okay. Anybody else have another idea of why we should not? It's an estimate of the average, okay, which kind of goes along with what we've already been saying, that this is not the actual average, it's just an estimate of it. Okay, but there's another reason why not. And it's related to what you just said. I'm sorry? It's not the correct average of the data? That's true also. But the other part is the points don't actually go onto the line. This is a scatter plot idea, okay? We know, or we can pretty much assume, these points do not actually go on the line. So to say that this thing has meaning is actually not true, because this is not telling us what is actually happening. If I put in something, I'm not getting the reality of the situation. Putting in numbers into a formula like this does not tell me what's happening, because the points aren't on the line. It's not a thing. It's not an exact line. So this just doesn't work. It's even though we have a formula, the formula does not tell us what's really happening, because the points don't actually go on the line. Just don't. All right. So there we have that thing happening right there. How would we interpret the fact that the slope is positive? Taylor, can you tell me how to interpret the fact the slope is positive? Oh, okay, Brianna, can you tell me how to interpret the fact that the slope is positive? Okay, that is the direction of the line, yes, but I specifically want to interpret this based on what I am measuring. Nikki, can you tell me?
I wrote down that there's a high slope, it's a strong positive relationship.
No, that's not what I'm after. Okay, Emily?
Is it that when one goes up, the other goes up?
Yes, specifically then for what we're talking about. What does that mean?
When poverty goes up, so.
Okay, so what we're saying here is that poverty and crime are positively associated, which means if you have more poverty, you have more crime. That's what this is telling us. Once again, it's not telling us that poverty makes crime or that crime makes poverty. It's just saying that they both happen more at the same time. If you have more of one, you also have more of the other. Okay, a social scientist would be able to say, okay, what does that actually mean in terms of the relationship? What's going on, right? Okay, so that's regression. Now, this process of finding these numbers is not something you'll be required to do on the test. I will give you the numbers as far as what the correlation coefficient is and what the regression equation is. But you'll need to be able to interpret them. You'll also need to be able to actually graph the values in order to make this line happen. Okay? So let me edit this again. Yep, that's fine. So here it is. Here's the line. What do you see? So what do you see? Well, that's good, but what does it tell you? Do you see anything special? Does anything jump out? Is there any information here?
Not really.
Not really? Okay. What direction is it?
Up.
Yeah, that's what we expected, right?
Well, yeah, but it's not really giving me the effect.
Okay, it's not really covering the data because the data is not on them, right? Anybody observe anything you might consider strange about this line? Or about the data itself?
There's more data values on the bottom here.
Okay, it looks like there's more data on the bottom than there is on the top. It's not supposed to happen. Why do you think that might be happening? Is this data a cloud? Is it scattered about in just a normal cloudy fashion? When you look at this, you say, hey, I see a cloud. Do you see a cloud of data? Is there any place where you don't see a cloud of data? Taylor? Way up in the corner. This is not a cloud. It's not part of a cloud. What is this? Okay, there's another word for it. A data value that's separated from the main data set. It's an outlier. This is an outlier. This is not in the cloud. Why not? Why is that data value not in the cloud?
Milwaukee's a horrible place to live.
Milwaukee is a lot different than any other place in Wisconsin. Horrible is a judgment call, which we won't make here, but we'll just say it's different, okay? It's a lot different, okay? Does Milwaukee have a lot higher poverty rate than any other county in Wisconsin? Yes. Does it have a much higher crime rate than any other county in Wisconsin? Yes. Should Milwaukee be considered to be the same as all the other counties in Wisconsin? No. All right? So it doesn't make sense for us to include Milwaukee in this analysis. Because if we're trying to figure out how do poverty rates and crime rates work, putting Milwaukee in there does not really compare it correctly with all the other counties, because it's just not like any of the other counties, right? Milwaukee is very different from all other places in Wisconsin. So why would we think that it behaves the same way as those other counties? We should not. Does it make sense to include Milwaukee? No, because it's not part of the data set in the sense of the cloud. This isn't a cloud. Milwaukee is an outlier. It should probably not be considered. However, at the same time, it is higher, which is kind of what we thought, right? The higher poverty, the higher crime. Milwaukee has high poverty, high crime. Does that help us? Does that make some sense? Well, I don't think it's legitimate to put Milwaukee in there because it's not part of our normal set of Wisconsin counties. All right. So anytime we do an analysis of a data set, we say, what is the data set telling me? We should not do it without actually looking at the graph. We said there is a positive relationship. We said this thing is going to predict the average. But when we look at it and we say this thing over here is very different than everything else, and it's going to kind of mess up everything. So we probably don't want to include it in there. Okay. So let's take it out. Oh, first of all, we do want to talk about R squared here. R squared is 66%. Okay, that's a measurement of the strength of the relationship using R squared. Well, now we're going to take out Milwaukee. Well, it changed everything. Our correlation coefficient is now 0.564. So we're still going to reject the null hypothesis, but not by a whole lot. Well, we did change our degrees of freedom, so that'll make a difference too. Anyway, it's okay. What's the formula? The formula is now different. It's 25, basically, plus 13.63 minus poverty. All right. And now it looks like this. Do we have a data cloud now? Is it more of a cloud than it was last time? Yeah. Who's way down there at the bottom? Waukesha. I don't know my Wisconsin geography. Is Waukesha a lot different than a place like La Crosse or Sheboygan? I don't have any evidence that it is, so we'll just leave it in for fun. How about that? Do we still have a positive linear relationship? Yeah, we do. Okay. Now, what we're talking about right here, this is dealing with having a linear relationship and then the formula. What about our R squared? R squared is now 32%. So now we're a lot less clear about how much poverty affects crime rates. It seems like it does affect it, but it's not as strong as we thought it was. Because Milwaukee's data kind of messed everything up. But now what we're looking at, it's a little bit more of a clear thing that it's not the only thing happening. It's quite a cloud here, not so much of exact straight line. Okay. Now, what we're going to deal with now are going to be the confidence intervals and the prediction intervals. Okay. And this is like what's on the second part of homework set number 15. Okay, but we're going to do it for this problem here right now. Okay, so I'm going to change this graph and I'm going to include the confidence interval and the prediction interval for this. And oops, I forgot to put the lines on here. I hope this works. There we go, that's better. All right. So here we have confidence intervals and prediction intervals. Well, let's look at La Crosse. Certainly, we should look at La Crosse. La Crosse has 14 poverty and 172 crime. So that's kind of on the high end here. Yeah, there's La Crosse right there. Okay. So let's look at if X is equal to 14. This would be the poverty rate. And I want to do two things. I want to know the confidence interval and the prediction. Now, what I asked you to do on homework set number 15 was to look at the graph and see what the graph had for numbers. So I didn't tell you what the numbers were. I just said, look at the graph and see where do the lines actually fall. But we're not going to do that here. We're just going to save ourselves a little bit of work. We're going to let the computer do it for us. So I'm going to put in an X value of 14. Oh, well, it's showing me that. That's fine. So my confidence interval is 167 to 264. And the prediction interval is 82 to 349. And I'm going to put some words in there. You have a question?
I just said, can you show me how you found them?
Sure, I will. Okay. Well, I'll show you right now. If we say that I have X is 14, that would mean I'm going to go over here. And I'm going to try to figure out where is this green section. What Y values do I have? And this is like 150, like 170, it looks like. Well, it's 167. Okay. And then the top one here, this is 200, 300, so it's like 265 or something like that. 260. Okay? And the same for the yellow ones. This is down here at about 82. This is up here, 349.
So I'm the prediction interval, we always thought, oh,
Yes, a lot bigger, yep.
okay.
Okay. So, what is the confidence interval supposed to tell us? Donna, can you tell me the purpose of confidence intervals? Oh, slow you down. Brienne,
It
oh,
tells, average.
it tells us the average, that's correct. And in this situation, it's telling us the average of the y values, right? So this is the average or the mean of the y values. So this is saying if I have a county with 14 poverty rate, then the average would be somewhere between these two numbers. So if I had all kinds of different counties and they all had a 14, and I said, what's the average? The crime should be somewhere in between here as an average. Well, what do I have as a prediction? Somebody tell me what this is predicting. Not predicting the average. What is it predicting?
95% of data.
Okay, this is predicting the data values, or the y itself. Okay, not the average y, but just the y. So if I have a county which has a 14 for the poverty rate, then I would expect their crime rate to be somewhere between like 80 and 350. Now, is that a very accurate prediction? No, not really. How much crime do you have? Somewhere between 80 and 350. That's a lot of difference, right? In fact, there's a problem here. What happens when we go down to this county down here? What are the predicted crime rates for this county? Negative. How can you have a negative crime rate?
We'll give them back.
Yeah, that's right. People go around and give other people stuff. They break into their houses and put flat screen TV. Right? That would be not really happening very much. So it doesn't make sense for this to have a negative number. Well, guess what? When we had Milwaukee in there, way up there at the top, then this prediction interval went down to negative 400. So no, it's not really legitimate for us to have Milwaukee in there. So what this is saying is, it looks to me like this doesn't really work because it's predicting something to be negative and it can't be negative. And that's what happens on your homework set 15, okay? On your homework set 15, when you look at the confidence interval, maybe it'll work. But if you look at the prediction interval on homework set number 15, it's negative. There's no way you can have negative vehicle thefts. Unless, like you say, people are breaking into garages and leaving cars, which is not really happening, okay? So on homework set number 15, on that second part, it just doesn't work to have negative numbers. So then, are they reasonable? No. If they come out to be negative numbers, it's not reasonable to have negative crime rates. Same thing is true here. So what we're saying then is, even though I have a straight line, and even though according to this, I have a linear relationship, if I try to actually use this information to predict what's happening, it's wrong. It's just wrong. It doesn't work. So if you remember, well, let's see, I can pull that up here. For homework set number 15, if we take a look at, and again, I'm focusing my attention on this part right here. If we look at this and we say, is there a cloud of data? Well, certainly it looks like a cloud right in here. But you know what? The cloud does not extend below 0. So I should have a cloud that goes all the way through this section. And I just don't, because this part down here is just empty. So the whole idea that I can use this to predict what's happening is wrong, because it's predicting negative crime rates. So that's why I'm telling you, when somebody does a prediction like this, and they try to use the data to tell you what's happening, if you don't have those prediction intervals and confidence intervals, you really don't know what's going on. And it could be that it's not really legitimate because it doesn't work. It's trying to tell you something that isn't there, which is the definition of being wrong. Okay, no, it's not. It's not there. So that's this second part of homework set number 15. When we ask the question, what's the relationship? If we have higher federal spending, we would have higher motor vehicle theft. The R squared is really pretty low, only 10%. So it's not really telling us much of anything. This doesn't really predict much. And then, even though our confidence intervals seem to be possible here, the prediction intervals are just impossible. So this doesn't work. To draw a straight line between these points is wrong. It's not really reflecting the data as it is. It's not a cloud. It's a cloud that stops at 0, and so that's messing up the whole thing. All right, that's the second part of homework set number 15. What's the first part of homework set number 15? Looks like this. Do you think that the curve is a better fit than a straight line? Okay, Eric says it is. Lisa says it is. Evie, you agree with them? Okay, so far so good. Can somebody tell me why you think the curve is a better fit than the straight line?
Because the R squared value is higher.
Okay, the R squared value is higher. That would be one good reason, right? R squared value is higher, makes sense. Any other ideas?
Correlation is closer to 1.
I'm sorry?
The correlation is closer to 1.
Yeah, the correlation is stronger, which is basically the same thing. It's just that that was squared. But either way, yep. Any other reason why you might think this curved line is a better idea? Yes, Kaylor.
Some of the data values actually fall on line.
Okay, it looks like it fits better. Okay, because when you look at the straight line thing, there's a whole bunch of data here that goes down below. So it's like, well, it shouldn't just go above and then below and then above. It should be a cloud, but it doesn't look like a cloud this way. Here, the dots are on both sides of that. So it looks like it fits better. So it's not just that the numbers come out better, it actually looks like it fits better. So that would be another reason why we would say, yeah, the curve is better. All right, you won't have to worry about this part on the test. We won't be doing that on the test at all. But you will need to be able to explain the idea of the confidence interval versus the prediction interval. What are those things measuring? Well, let's talk about La Crosse. La Crosse is over here. What would we say about the city of La Crosse in terms of its crime rate? Based on where that dot is located. Allie, can you tell me what you think about lacrosse? Because it's right here. Okay. Emily Grenier, can you tell me what you think about lacrosse?
It's kind of like on the lower.
Seems to be a bit on the lower side of things. It's almost, you could even almost say it's below average, right? Because the green part is average. So lacrosse is kind of below average as far as crime. Based on poverty, the amount of poverty in lacrosse, it's below average in crime. Would we consider it to be an unusual value? No, because it's still within the yellow. Well, somebody up here is kind of bordering on the crazy, right? They're almost off the charts, literally, with regards to their crime rate. So there's something going on there besides just poverty. Poverty is not the real explanation for that. Something other than poverty is going on that county. I don't know what it is. Who is it? Row 1. Okay, who are you, row 1? Brown County. I don't know anything about Brown County. But according to this, they're pretty high up there as far as crime, not related to poverty. There's something else going on. I don't know. But remember, we even said this whole thing was not legitimate because it went down below. So anyway, there we go. All right. Now, what's really nice about this situation is that I'm not going to require you to turn in homework set number 15 because we just all went over it in class. So we'll just keep it like that. So we'll just say you all get credit for doing homework set number 15. All right. So that'll make it a little bit easier for me because I don't have to look at what you're doing. How's that? All right. So, yeah, I'm kind of crazy at this point. We're going to go ahead and take our break right now. Okay. So we're going to come back at 3:54. And if we need to take another break, we will, because it's going to be a while. So we'll come back at 3:54. So this is 1st of August.
So if we had to explain it.
I was wondering when I wrote that.
Yeah, over there is here, but other Danielle's not.
I knew it would be average.
Vicky is here. Kelly is here.
And then
Everybody's
and this should just be like the benefit.
Oh, this one.
The prediction.
Casey's.
So this one should, they should both.
No, this is average of Y, and this is Y.
Oh, okay, yeah.
This year. Okay, there we go.
I know I'm 1 minute.
I know, yep. I just don't get